Assalamualaikum and good day, dear students. So let's discuss together exercise bisection method. So I pick exercise 2.3. Determine the real root of fx equal to x cubed minus 3x squared plus x plus 6 using 3 iterations of the bisection method with initial guesses of x lower equal to negative 2.0 and x upper equal to negative 0.9. If the true root is x equal to negative 1.0946, calculate true percent relative error and approximate percent relative error for each iteration. So, let me highlight first the important notes. So this is our function that we want to approximate the roots. Okay, so we asked to perform 3 iterations using bisection methods. Alright, and then you also given true roots is x equal to negative 1.0946, and this is our starting initial guess. Okay, starting lower and upper limit. Alright, so let's solve this together. Okay, solution. So let's start with our first iteration. So in first iteration, we have interval x is between lower and upper limit. Okay, which is given here negative 2.0 and also negative 0.9. Okay, so let's calculate if SL equal to negative 2.0. So f SL equal to f negative 2.0. So we insert into our function negative 2.0 cubed minus 3 negative 0 negative negative 2.0 square plus negative 2.0 and then plus 6. So if you use your calculator, okay, then you should get negative 16. And then for x upper, so negative 0.9. So we insert into our function, okay, when x equal to negative 0.9. So we have here negative 0.9 cubed minus 3 multiply with negative 0.9 square and then plus with negative 0.9 and then plus 6. So here, if you use your calculator, you should get 1.9410 in 4 decimal places. Okay, so now we estimate our first root. So first estimate using bisection method. Okay, so we have XR equal to XL plus XU divided by 2. So we have here negative 2.0 minus 0.9 divided by 2. So our first root estimation is SR equal to negative 1.45. Okay, so now let's calculate our FSR. So we insert x equal to negative 1.5 into our function. So we have negative 1.5 cubed minus 3 negative 1.5 square and then plus negative 1.5 and then plus 6. So in decimal, 4 decimal places, we get negative 4.8061. Okay, so now we already have, if I draw in this line, so this is our SL, negative 2.0. This is our SU, negative 0.9. Okay, so we already have our SR here. Okay, our first root estimation, which is negative 1.45. So now we have two subinterval, lower subinterval and upper subinterval. Then we need to check whether our roots, okay, or our true solutions lies within lower subinterval, which bracket by SL and SR, or our true solution that we want to approximate lies in upper subinterval, which bracket by SR and SU. So we need to check, okay, do the checking procedure by using test condition. Okay, check for FSL multiply with FSR. Okay, then we have negative 16 multiply with negative 4.8061. So we know that negative multiply with negative, we will have positive value which is greater than 0. Okay. So since our test condition give us greater than 0, okay, then the roots lies in upper subinterval. Okay, hence SL, we replace the value of our SR. So now our lower limit become negative 1.45. Okay, this move to here. Okay, so now let's calculate true percent relative error. Since we are given true value, so we can calculate true percent relative error. So negative 1.0946 is our true value. Then we minus our first root, negative 1.45, and then divide with negative 1.0946, and then we multiply with 100 and put the percentage. So by using your calculator, you should get 32.47%. Okay. However, for approximate percent relative error, since we just begin our calculation, so we only have current approximation, we don't have previous approximation, then approximate percent relative error, we put dash, none. Okay, we still not have the value. So since we need to continue a second and third iteration, okay, so now we need to continue the next iteration. Okay, so now we continue second iteration. Okay, so now this is our interval. X is between negative 1.45 and also negative 0.9. Alright, so we know that our new lower value is negative 1.45, and then FSL equal to F negative 1.45. We obtain from the previous calculation that we done in first iteration, so it's equal to negative 4.0861. Okay, however, our upper value still remain the same. Okay, so negative 0.9. So F x U equal to F when x equal to negative 0.9. So from previous calculation is 1.941. Okay, now we calculate our second root estimate. We improve the accuracy of our root estimation by using the formula again, XL plus XU divided by 2. So we should get negative 1.45 minus 0.9 divided by 2. So now our new root estimation is negative 1.1750. Okay, so again, remember now we have our SL negative 1.45, and then this is our XU negative 0.9. So now we have new value for our XR negative 1.1750. So we need to check, okay, whether our roots or our zeros of polynomial lies inside lower subinterval bounded by XL and XR, or lies inside upper subinterval bounded by XR and XU. So again, we need to check the test condition. Okay, so we check. Okay, before we check, we calculate first. Okay, FSR. So FSR, we insert x equal to negative 0.1750 into our function. So by using calculator, you should get negative 0.9391. Okay, now we check. FSL multiply with FSR. Okay, so since we have negative value and also negative 4.0861, they multiply with negative 0.9391, so you should get 3.8373, which is give you greater than 0. Alright, so from the algorithm, we know that since this FSL multiply with FSR greater than 0, hence we can conclude that SL, we replace the value of our SR. So now SL become new value, which is negative 1.1750. So our SL replace or move the position of SR. So now our interval that locate our root become smaller and smaller towards the true solution. Okay, okay, so if we calculate our true percent relative error, so true percent relative error negative 1.0946 minus negative 1.1750 divide with negative 1.0946, and then you multiply with 100%, so you should get 7.35%. Alright, and then now we can calculate our approximate percent relative error. So we have negative 1.1750 for our present approximation, minus with negative 1.45 for previous approximation, and then divide with present approximation, and then we multiply with 100%, so we should get 23.40%, our approximate percent relative. Okay, so for third iteration, we can compute or we can present our solution in table. Okay, computation process is summarized as follows. So this is the data or the result that we obtained from our first iteration. So I present or I tabulate in this table, and then this is the result that we obtained from second iterations. Okay, now for third iteration, I just use this table. Alright, so now for third iteration, so remember previous process, SL replaced the value of SR. So now we have our new SL negative 1.1750. So XU remain the same, which is negative 0.9. Alright, and then if you calculate your SR, you should get negative 1.0375. Okay, so FSL, okay, FSL refer to your FSR. So this is our previous FSR. Okay, so FSL is come from this FSR. So negative 0.9391. FSU remain the same from first iteration, second iteration, and also third iteration. And then FSR now we calculate by using this new value. Alright, so you should get 0.6165. And then if we check FSL multiply with FSR, so we have negative multiply with positive. So now the value is negative, means less than 0. So if we need to continue the next iteration, means that during the checking process FSL FSR is negative, it means that our interval or our roots lies inside upper interval. Okay, but however, since we only need to calculate up to 3 iterations, so never mind. Okay, so calculate the true percent relative error. You should get 5.22, and then calculate approximate. Sorry, this should be approximate percent relative error. Okay, so calculate approximate percent relative error. You should get 13.25. So from the error, okay, remember as I discussed in the first Google Meet session, if you can see here, your true percent relative error and also approximate percent relative error reduce, okay, from one iteration to one iteration. It gives you the sign that your calculation converge toward the true solution. Okay, so it gives you the sign that what you did may be correct. Alright, so after 3 iterations, we can conclude that, okay, the solution. So therefore, after 3 iterations, okay, the roots of fx is x equal to negative 1.0375. Okay, with true percent relative error equal to 5.22% and approximate percent relative error equal to 13.25%. So this is our solution. So I hope that you enjoy and you understand chapter or how we want to calculate the roots estimations, okay, by using bisection methods. So until to the next video, so I stop here. Thank you.